All the physical laws in the universe are delicately balanced and specifically measured for the existence and support of life. The general structure of the universe, the place of our Earth in that universe, our planet's physical features such as air, light, and water all possess properties that are essential to our survival. When we inspect and study at the molecular level, the special creation of the microcosmic world reveals a clear and an even more unique order. At the molecular level, or smaller, such as the atomic level, which is too small to be seen with the naked eye, everything is flawless. The elements that make up our hands, eyes, hair, and lungs, or all of the living things such as plants, animals, trees, and birds that provide food for us, are all specially created building blocks. In his work, The Universe, Plan or Accident, the physicist Robert Clark describes how the building blocks of life were brought into being with a very special and a very superior creation. As if the Creator has given us a kit of prefabricated parts ready-made for the work in hand. One of these special components referred to by Clark is the element called carbon. In many respects, carbon has different properties compared to other elements. These differences make it essential to life. Carbon is the sixth element in the periodic table. Its most important characteristic is that it constitutes the basis of many things on Earth, from our car tires to our computers, from the natural gas we use to cellulose, from the meat we eat to the DNA in our cells. The film you are about to watch provides information about the structure of carbon and allows you to witness a great proof of creation. The element carbon, the basis of all life, is only produced as the result of very special and miraculous reactions in the centers of giant stars. If these miraculous reactions did not take place, there would be no such element as carbon in the universe today, and thus no such concept as life. We describe these reactions as miraculous because they only take place in conditions that are impossible under normal circumstances when they combine together. Let us now examine this phenomenon. The carbon atom comes into being as a result of a two-stage process in the nuclei of giant stars. Two helium atoms first combine together, resulting in an intermediate element with 4 protons and 4 neutrons. This intermediate element is known as beryllium. When a third helium atom is added to beryllium, the result is a carbon atom with 6 protons and 6 neutrons. The beryllium that emerges in the first stage has a different structure to the beryllium found on Earth. The ordinary beryllium in the periodic table has an extra neutron. The beryllium that forms inside red giant stars, on the other hand, is a different version. Chemists call this an isotope. Physicists have long been amazed because this beryllium that forms in red giants is abnormally unstable. It is so unstable that it disintegrates in as little as 1/400th of a second after it is formed. So how is it that this beryllium isotope that vanishes the moment it forms turns into carbon? Does the helium atom that will convert the beryllium isotope into carbon approach and bond to it by chance? Such a thing is, of course, impossible. It is just as, or even more impossible, as a third brick being added on top of two other bricks that have come to be standing on top of one another by chance in as little as a trillionth of a second, before the first two bricks collapse, and in such a way a sound piece of construction emerges. The famous scientist Paul Davies describes this miraculous phenomenon in these words. Carbon nuclei are made by a rather delicate process involving the simultaneous encounter of 3 helium nuclei inside the cores of large stars. Because of the rarity of triple nuclear encounters, the reaction can proceed at a significant rate only at certain well-defined energies, called resonances, where the reaction rate is greatly amplified by quantum effects. One of these resonances is positioned just right to correspond to the sort of energies that helium nuclei have inside large stars. A process known as double resonance takes place in red giants. When 2 helium atoms resonate in union, another resonance causes a third helium atom to join the beryllium atom that emerged in as little as 1/400th of a second, and thus give rise to carbon. This is a phenomenon that cannot possibly take place under normal conditions. George Greenstein describes why this double resonance is such an extraordinary mechanism. There are 3 quite separate structures in this story: helium, beryllium, and carbon, and 2 quite separate resonances. It is hard to see why these nuclei should work together so smoothly. It is like discovering deep and complex resonances between a car, a bicycle, and a truck. Why should such a disparate structure mesh together so perfectly? Upon this our existence, and that of every life form in the universe, depends. Greenstein compares the formation of carbon in the nuclei of giant stars to a phenomenon that could not possibly occur spontaneously, but is reluctant to unequivocally describe this as a miracle of creation due to his belief in materialist dogma. It subsequently emerged that certain other elements, such as oxygen, also form by way of such extraordinary resonances. Fred Hoyle, who first discovered these extraordinary processes, concluded in his book, Galaxies, Nuclei, and Quasars, that this process was far too planned to have come about by coincidence, and despite being a committed materialist, he admitted that the double resonance he discovered was a regulated matter. In another article, he stated the following: if you want to produce carbon and oxygen in roughly equal quantities by stellar nucleosynthesis, these are the 2 levels you would have to fix, and your fixing would have to be just about where these levels are actually found to be. A common-sense interpretation of the fact suggests that a super-intellect has intervened in physics as well as chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to be so overwhelming as to put this conclusion almost beyond a question. So influenced was Hoyle by this miraculous phenomenon that he stressed how other scientists could not ignore this obvious truth. I do not believe that any scientist who examined the evidence would fail to draw the inference that the laws of nuclear physics have been deliberately designed with regard to the consequences they produce inside the stars. It has been estimated that there are currently around 2 million compounds on Earth, with different structures combined in various ways. In the same way that these compounds may be able to form solely by two atoms combining together, they can also emerge from a combination of millions of atoms. The interesting thing, however, is that the fact that every element has its own particular ability to produce compounds. Some elements never combine with another element under any circumstance. Some produce only one or two compounds. Carbon, however, is very different to all of these. It is able, by itself, to establish 1.7 million compounds of different kinds. Bearing in mind that the total number of different compounds in the world is 2 million, we see that all the other elements, excluding carbon, produce the remaining 300,000 compounds. The meaning of this is that carbon is a great marvel of creation. It is also very interesting that there is actually quite a small amount of this vitally important element. Carbon represents only 9 to 10% of living bodies in weight and only 17 parts in 100,000 of the Earth's composition. Despite being present in only small quantities, carbon is still present in every part of our lives, including our own bodies, and there is no other element that can replace it. Carbon's property of being easily able to form compounds with other elements stems from the bonds it establishes. Because of its molecular properties, carbon is able to add atoms of the same type